ever really thought about how we know the exact size of something? Or how we can explain the difference between a car driving down a road and a kid on a swing? Well, today we're going to dive into the world of measurement and motion. And believe it or not, it all kicks off with a pretty common problem. So meet Deepa. She's a student, just like you, and at the start of the school year, she ran into a little issue. It's a problem I'm guessing a lot of us have had before. Any ideas what it could be?
Yep, you guessed it, she's grown taller. Her old school uniform just doesn't fit anymore. It seems like a simple problem, right? But it's about to lead us to some really big questions. See, to get a new uniform, Deepa and her mom need to do a whole lot of measuring. And this is where things start to get really interesting. Because as they find out, not everyone measures things in the same way. Deepa's day of measuring was, well, kinda all over the place. At the cloth shop, the shopkeeper uses this big, stiff metal rod. Then, the tailor uses a soft, flexible measuring tape that can wrap around her arm. And then get this, her mother even suggests using char angula, which is basically just the width of 4 fingers. So you've got a rod, a tape, and fingers. 3 totally different ways to measure one thing. And that's the big problem, isn't it? If one person is using a metal rod and another is using their fingers, how can we ever be sure we're talking about the same exact length? How do we stop all the confusion? Well, this whole puzzle sparked an idea for Deepa and her friends. So, back at school, Deepa tells her friends all about her weird measurement adventure. And instead of being bored, they actually get pretty excited. They decide to run their own little experiment to try and figure this whole thing out. Okay, so here's their master plan, super simple. They're going to measure the length of their classroom table, and their special measuring tool, their own hands. They decide to use a handspan, the distance from the tip of your thumb to the tip of your pinky when you stretch your hand out wide. So they each carefully measure the table and write down what they got. But take a look at this. Deepa measured 14 handspans, and Nish got 13. Hardeep was somewhere in the middle with 13.5, and Padmo got 14.5. It's the same table, so why are there 4 different numbers? What is going on here? And here's the light bulb moment. The reason they all got different answers is, well, it's because their hands are all different sizes. Using a body part like a handspan just isn't very reliable if you need everyone to agree on an exact measurement. And this leads them to a huge realization. So yeah, their little experiment proved it. Using your own personal or, non-standard units of measurement just leads to a whole lot of confusion. There's got to be a better way, some kind of rule that everyone can follow. And this is that aha moment. Deepa suddenly gets it. She thinks, oh, that's why people use things like rulers and measuring tapes. It's not because they're fancy, it's because they're based on something that everyone everywhere can agree on. And that brings us to the super important idea, the standard unit. A standard unit is just a measurement that doesn't change. It's the same for you, it's the same for me, it's the same for an astronaut on the space station. A centimeter is always a centimeter. Okay, so if we're not using handspans, what do we use? Well, the most common system in the world is the metric system, and it gives us a whole family of units just for measuring length, from super tiny things to really, really big distances. It's all based on the meter. For teeny tiny things, like how thick a piece of paper is, we use millimeters. Put 10 of those together and you get a centimeter. 100 of those makes 1 meter, perfect for measuring, say, the length of a room. And for really long distances, like from one city to another, we use kilometers, which are just 1,000 meters long. See? It all connects. But it's not just about knowing the units. You've got to use the right tool for the job, right? You wouldn't use a giant tape measure made for roads to measure your pencil. You just use a regular old ruler. And if you want to measure something round, like a tree trunk, a stiff ruler is useless. You need something flexible, like a measuring tape. Okay, so we have totally nailed how to measure things that are just sitting there. But what about all the stuff in the world that isn't standing still? What happens when things move? This brings us to the whole second part of our story, motion. So here's our next big question. It's one thing to know where something is, but how do we describe how it's moving? Did it go in a straight line? Did it go around in circles? Did it swing back and forth? We need a way to talk about it. Well, luckily for us, scientists have already done the hard work. They've figured out that most movement can be classified into a few basic types. And the cool part is, you see these types of motion all around you every single day. Let's break them down. First up, We've got linear motion. This one is super straightforward. It's just movement in a straight line. Think about a car driving down a long straight highway or soldiers marching in a parade. Boom, that's linear motion. But of course, not everything moves in a straight line. And that brings us to our second type, circular motion. This is pretty much what it sounds like. It's any object moving along the path of a circle where its distance from a centered point stays exactly the same.
A horse on a merry-go-round is a perfect example, right? It just goes round and round. Or, get this, think about the wheels on Deepa's school bus. Even while the bus itself is in linear motion, its wheels are spinning in perfect circular motion. It's all movement along a circular path. And for our third and final type, we have a really cool one. It's called oscillatory motion. Now I know that word sounds a little complicated, but the idea is actually super simple. It's just a motion that repeats itself by moving back and forth over and over again. You have definitely seen this a million times. The absolute best example is a child on a swing at the park. They go forward, then back, repeating that same movement. That to and fro rhythm is oscillatory motion. So, there you have it. We started with a pretty simple problem, Deepa needing a new uniform, and we ended up unlocking the secrets of standard measurements and the basic ways everything moves. From the school bus to the playground swing, it's all just physics in action. So now it's your turn. I want you to look around you right now. Can you spot all three types of motion? I bet you'll start seeing them absolutely everywhere.